ihasmath, and you're going to learn how to draw a line graph from an equation. I'm going to show you 3 different methods that work and tell you about the advantages that each of them has. There are a few special cases that I'm going to cover in the next video, but this one will prepare you for most line equations. The first method you've already seen in the video on number patterns. I'm using the equation to generate a number of coordinates that I can then copy into the graph. Most of the time, I'm just using the values 0, 1, 2 and 3 for x, but you could use other values as well. I substitute them into the equation to find the y value. Both x and y together give me the coordinate that I can then draw in the graph. As x and y are just abstract variables here, I can treat them as continuous and draw a line through them and extend the graph in both positive and negative x direction. Lines go on forever, so some people indicate this with little arrowheads. This method will always work. Actually, also for other equations that don't result in line graphs. However, it takes the longest and it's quite a bit of work. One good thing about it is that it makes you aware of mistakes that you might have made. For example, if you had worked out the coordinate 2, 5 instead of 2, 4, you could easily see that this point isn't in line with the others and you could check your calculation. The second method is similar to the first one, but it uses a graphics calculator to generate the table. I'm using this new fancy Casio one, but it basically has the same functions as the older model that you're probably using. In order to get to table mode, press Menu and select Table. This should be the number 5 button for you. If there is already an equation in there, delete it first. Notice that there is a y on the left-hand side already, so I just have to enter the right side of the equation, in this case 3x minus 2. Type in 3 times, and for x I have to use the x theta t button that's right underneath the red alpha button. Finally minus 2 and press xe to execute. Next I need to decide which x values I want from a table. I can do this under F5 for set. I want to start with 0 and end with 3 just like before, so step 1 is okay. It just means that the calculator will take all the whole numbers from 0 through to 3. You can play with the settings and see how this changes your table. Confirm with xe again. Finally, pressing F6 for table gives me the same table that I got earlier when I did this the slow way. Again, I would then copy the coordinates into the graph and connect the points. Once you've got a little practice with this method, it's quicker than working out the table yourself. Just like the first method, it works for other equations as well, so this will really be handy later on. My last method uses gradient and y-intercept. It's by far the fastest one for drawing most lines, and it allows you to also answer higher level questions that require you to interpret a gradient or a y-intercept. You know already that in the general line equation y is equal to mx plus c, m, so the number in front of the x, is the gradient. C, the number without the x, is called the y-intercept. This gives you the point where the line crosses the y-axis. Let's have another look at our example. We can see that the line crosses the y-axis at -2. And we could have known that before because the y-intercept in the equation was -2. Also, we can see that the gradient is 3 over 1, or simplified, 3. And again, we can see the 3 in the equation as the gradient. Let's try a couple of examples. There are a few special cases here. If there is no number in front of the x, the gradient is 1, because x is the same as 1x. If there is no x in the equation, the gradient is 0 and the line is parallel to the x-axis. Finally, if there is no number without an x, the y-intercept is 0 and the line will cross through the origin. This gradient intercept method needs practice, but it's worth it. It's by far the quickest way to draw line graphs from an equation if it is given in the form y is equal to something. If you want a break from your normal practice but still continue learning, you could try the Desmos activity in the link below. It's a puzzle game where you need to change the gradient and y-intercept of line equations in order to collect all the stars.